Hey there students, Mr. Fugit here. In our video today, we're going to be looking at another sample problem involving forces. Specifically here, we're going to be looking at a problem involving a tension force. Oh, might have bumped out of that there, sorry about that. So in this problem, depending on the year in which you're watching the video, this is going to be one of our problems from a Quest homework assignment dealing with some of our tension forces. So should be a good chance for us to apply what we learned about forces and Newton's second law. Okay, so I've got my problem here. So here's our problem statement. It says we have a cat burglar suspended from a series of cables. Looks like here we've got a kind of our person. I'm just going to draw that with a dot here to kind of keep things simple. And we have one cable and another cable kind of here and then a wall. And we've got our person here, and then I've got that the angle here is 30 degrees. And I'm told that the burglar has a weight of 645 newtons. Okay, so weight, 645 newtons. And the first part of the question wants us to find the tension force in the inclined cable. So that's going to be, so I'll kind of color code these to make it easier. That's going to be this blue cable. So we'll start by, how do we set up to find the tension force in the cable? Okay, so we've got a little bit of a picture here. So let's take that and maybe draw a free body diagram. So we've got our person here, which we'll show with a dot. Okay, so what forces do we have on the person? Well, we have the person's weight, which remember, weight is synonymous with force of gravity. So we have the weight of the person, which is their force of gravity. Be careful here, that is given to you in newtons, so we don't need to do any extra math with that because it's already in newtons. If we were given a mass, we would need to use our force of gravity equation, m times g. But we're given the weight in newtons, meaning we're already given that force reading. And then for our purpose, I'm going to go ahead and color the inclined cable blue, and I'll call that FT1. And I'm going to color the second cable red, and I'll call that FT2. I believe this is a two-part problem, so we're first going to find the tension in the inclined cable, then in, I think the problem calls it the horizontal cable. So we're going to find FT1 and then FT2. I'm calling them FT1 and 2 for our sake. Now we are given this angle that the inclined cable makes with what appears to be kind of the roof in this problem, with the ceiling. So that angle, geometrically, is the same as this angle here with the horizontal. And that's going to be a bit easier for us to analyze, and it's a bit more similar to what we've already done. So, I'm going to go ahead and label this as 30 degrees. And now again, your numbers are going to look different in your problem. Here I'm looking at my numbers from my set of problems here. Okay, so let's first look at how we can find FT1. Now, broadly, when we have, let's say, a vector like this, a force vector, in order to find, in order to find its magnitude, we need to know usually a couple of pieces of information. Sometimes we need to know the components, the x and y components. Sometimes we might need to know, one component and one angle. But here's what we've got. Since this cable is at an incline, that means we're going to have an x and a y component. Now, in order to find our overall magnitude, which is what the question wants, we probably need to find one of those forces. So how do we go about doing that? Well, the only other force we know is our weight. So we may have to look at how we can sum up our forces to figure out what's going on here. Now, the problem statement might not be as clear, but based on the description of the scenario, it appears that the burglar is at rest. Or I think I might use the language suspended or supported by. It's trying to help us see that he's just, or she's just, the person, just hanging there, holding on to the cables. Now, I'm going to try to use the force that we know, the weight, to see if I can figure out some of the other forces involved here and get my way to finding that tension force for the inclined cable. So here's what we've got. Sum of forces on the object, on the burglar, is equal to the burglar's mass multiplied by the burglar's acceleration. Now, I know a little bit about the weight. I know what that is. So I'm going to start there. So I'm going to look at the sum of forces in the y direction. So here's what I've got. I have the y component of my inclined cable. That will be positive. And then I've got the x component of that inclined cable. That would be negative or positive as well. And then I've got this horizontal cable. That would be a negative component. Don't know what that is yet, but I just want you to see here. In order for the burglar to be suspended at rest, the forces have to balance out. Meaning the total force we have in the positive direction, vertically, has to balance out with the total force in the negative direction, vertically. So here's what we've got. We've got Ft1, that's our inclined cable, in the y direction, minus our force of gravity, should equal the burglar's mass multiplied by the burglar's acceleration. Now, we don't know what the burglar's mass is. We could work back and find that, but we do know what the burglar's acceleration is. They're not speeding up or slowing down at all. They're just suspended there, hanging there on the cable. Which means if they're at rest, we're not accelerating, not moving at all. So any number multiplied by 0 is just 0. So now I've got Ft1y minus my force of gravity, which my value was 645 newtons. That's the weight of the burglar, their force of gravity. So minus 645N is equal to any number times 0 is just 0. So now I can add that term over. Right, I'm adding that 645 over to show that the y component of that inclined cable is 645 newtons. Here's what we need to understand. In order for the burglar to be supported there, suspended in air, all the forces in each direction must balance out. So, the only thing to balance out the burglar's weight is the y component of that tension force. Right? So, now that we have that, we now know a component and an angle that we can use to find our overall tension force. Here's how we're going to do that. We've got Ft1. I'm calling that Ft1, that's the inclined cable. We don't know at this point what Ft1x is, the x component of that force, but we do know what Ft1y is, 645 newtons. We also know the angle that magnetic force makes with the horizontal is 30 degrees. So now I'm going to take those two components and see if I can use some trigonometry to find my final answer. So, opposite hypotenuse, so my angle is here touching the horizontal, opposite to hypotenuse, that means I'm going to use a sine function. So, sine of 30 degrees is equal to, well, the opposite side would be 645 newtons, divided by the hypotenuse, which is just the magnitude of Ft1, right? So, to get Ft1 by itself, it's in the denominator. I'm going to go ahead and multiply that up to the numerator. Multiply up by Ft1. So Ft1 over Ft1, those cancel out. And then, to get Ft1 by itself, I'm going to divide both sides of our equation by sine of 30 degrees. So, sine 30 over sine 30 cancels out. And now, I'll get Ft1 is equal to 645 newtons divided by sine of 30 degrees. So, let's plug this in. 645 divided by sine 30, and I get a value of 1,290 newtons. Ft1 is equal to 1,290 N. And there's our answer for the tension in the inclined cable. Okay, so hopefully that gave us a pretty good idea on how to set things up. Remember that when we're working with these problems, we always start with a free body diagram first, and then we'll move to Newton's second law. One of the things that can be a little bit tricky about this problem is making sure we understand that those are kind of two different tension forces, right? Because we have one at an angle and one that is horizontally, to the left. So we kind of treat them as if, the problem doesn't do a great job of clearly stating this, but we're going to treat them as if they're two different tension forces. Okay, so now we're going to move into the second part of the problem. I'm going to check my, 1290 was my answer. Okay, so now the second part of the problem wants us to find what's the tension in the horizontal cable. So now, because that's in the x direction, I'm now going to use Newton's second law in the x. But I'm going to take the information I found for Ft1 to help me get there. So in the x direction, I have the x component of ft1, and then I just have ft2, because it's only in the x direction, so there's no y component. I don't need to say ft2x, because all of ft2 is in the x. So, here we go. Sum of forces in the x direction is equal to mass multiplied by acceleration. So in the x direction, we have ft1x minus ft2 is equal to the burglar's mass multiplied by the burglar's acceleration. But remember, the burglar has an acceleration of 0 because he's just kind of hanging out there at rest. So ft1x minus ft2 should equal 0. So now we just need to figure out what is ft1x, and we should be able to find ft2. So what do we know about ft1? Well, we found a moment ago ft1 is 1290 newtons. ft1x we don't know. ft1y we found to be 645 newtons. And we know our angle here is 30 degrees above the horizontal. So at this point, we could use, we could use a tangent function. Tangent 30 is opposite divided by adjacent. We could use a cosine function. Cosine 30 is adjacent over hypotenuse. Or we could even use the Pythagorean theorem. I'm going to go ahead and use a cosine function. I'll show you why. Cosine of 30 degrees is equal to our adjacent side, ft1x, divided by the hypotenuse, 1290. And now to get ft1x by itself, I'll multiply it up by 1290 newtons, 1290 newtons. And any number divided by itself is just 1. So now to get ft1x, I'll take 1290 cosine of 30 degrees. So now let's plug in and see what we can find. 1290 cosine 30, I get 1117.2. So ft1x is 1117.2 newtons. Now if I plug that back in, I've got 1117.2 newtons minus ft2 is equal to 0. So if I add this term over, I get that ft2 is equal to 1117.2 newtons. And there's our answer for ft2. Because ft2 should help us balance out the horizontal components of our forces. Right? We've got ft1 that's helping us balance out horizontal and vertical, and then ft2 that helps us balance out the horizontal forces. So hopefully this gives us a pretty good idea on how to set up this problem on our homework. It's a great example of using a free body diagram and applying Newton's second law. We have a little bit of complexity here with some of the trigonometry that's going on, but these are good applications for a lot of the problems that we'll see throughout the year. So, as always, if you have questions, please feel free to let me know. Other than that, good luck.